Define the term centroid. Centroid of a plane figure is a geometrical center where entire area of the plane figure is assumed to be concentrated. And in the simple words, we also refer that as mean position of all the points on a shape. So this term centroid plays a lot of importance, has got a lot of importance, especially when we are trying to do the stability analysis of the structures and when we do the motion analysis of any of the bodies. This term centroid is has got lot more importance when we consider it into the extended topics of stability of structures and motion analysis of the bodies. Define centrifugal force and centripetal force. Centripetal force is the force that is acting on the body, which is moving in circular path and it is directed towards the center of the circle. And this is responsible for continuously changing the direction of motion and keep the body in circular motion. So this is a real kind of a force. Next is centrifugal force is an apparent force or pseudo force or an imaginary force that is acting on the body which is in circular path and it is directed away from the center of rotation. So this is a reactive force experienced in the rotating frame of reference due to inertia of the moving body. So both the forces have a same formula that is given by mv square by r. R is the radius of circular path, m is the mass of the particle, v is the velocity of the particle with which it is moving. The question says about two rectangles of size 100 mm by 10 mm is used to form a L section and the centroid for this L section is to be determined. So first is that this would be x and y axis and areas of the each rectangle needs to be computed. So the area of each rectangle, that is height is 10 and the width of each rectangle is 100 mm. Let's say this is area 1 and this is area 2. So this width would be also 100 mm and thickness of this is 10 mm. Now the area of 1 and 2, that is A1 is equal to A2, that is 100 into 10, which is 1000 mm square will be the area of each rectangles. Now the centroid is required to be determined with respect to x as well as with respect to y axis. So here is the formula of the centroid, that is x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. Next is y bar, that is a1 y1 plus a2 y2 divided by a1 plus a2. So now the centroidal coordinates for the area number 1 and area number 2 is to be written. So let's say x1 and y1 are the coordinates, centroidal coordinates of the area 1. So for area 1 it is 100 by 2, that is x1 is 100 by 2, which is 50, and for area 1 the y coordinate will be 5 mm. Same way for area 2 the x coordinate will be 5 mm, that is x2 is 5 mm, and the y coordinate will be, that is y2 will be, we need to measure the distance from the x-axis. So there is a distance of 10 units or 10 mm above the x-axis. The area number 2 is 10 mm above the x-axis. So this is 10 plus the width of the rectangle is 100 by 2, that is equal to 60 mm would be the centroidal coordinate of area number 2. Now all that we have to do is the substituting the above values in the x bar and y bar equation. So a1 is 1000 into x1 is 50 plus A2 is also 1000 into x2 is 5 divided by A1 plus A2 it is. A1 plus A2 that is 2000 it is. So that is 2000. So here we get it as 1000 and 1000 will be cancelled. So this is 1000 common. So this is 1000 divided by 2000 into 50 plus 5 that is 55. So the answer is 55 by 2, which is also equal to 27.5 mm. That is the x coordinate. Same way the y coordinate is also required to be computed. That is 1000 into the value of y1 is 5 plus the value of a2 is 1000 and y2 is 60 whole divided by the area is a1 plus the whole divided by, that is 1000 into 60 whole divided by 1000 plus 1000, which is equal to 65 into 1000 divided by 2000. So this is 65 by 2, that is 32.5 mm would be the y coordinate of the L section. Write the moment of inertia about the centroidal axis for quadrant if the radius is r. So quadrant means the 1/4 of the circle needs to be considered. So let me just draw the circle. So this is this, and for this portion we need to write the moment of inertia for this remaining portion, and the inertia should be considered about the centroidal axis. So the centroidal axis is expected to be somewhere here. The centroidal coordinates are 4r by 3 pi and 4r by 3 pi from the edge. So now here if we apply the parallelogram now here if we apply parallel axis theorem, then that is I is equal to I bar plus a times of d square. So it is going to be a complex expression. So instead you can memorize that, that is moment of inertia about x axis as well as y axis. This is equal to 0.055 r power 4. This would be for the 1/4 of circle. In the question, it says about a right angle triangle whose base is 30 mm and height is 50 mm, and it is placed in such a way that the base is parallel to horizontal, and the moment of inertia about the horizontal centroidal axis and about the base is to be determined. So the height is 50 mm and the base is 30 mm. So bit A is talking about moment of inertia about the centroidal axis. The centroidal axis will be at a distance of 50 by 3 from the base, horizontal, centroidal, x-axis. So moment of inertia about the centroidal axis is given by b into the dimension that is perpendicular to the axis should be raised with power 3, and this is divided by 36. So that is 30 into 50 power 3 divided by 36. This is equal to 104 166.66 mm power 4, and the bit b, that is moment of inertia about the base, it is bh cube by 12, which is 30 into 50 power 3 divided by 12. This is equal to 375.0000 mm power 4. So remember that the dimension perpendicular to the axis should be raised with the power of 3. Yeah, let me just correct. The answer is not 375.0000. It is actually the product of 30 into 50 power 3. And the correct answer is 312.500 mm power 4. In the question, it says about the moment of inertia about centroidal x-axis for the C section needs to be found out. So here, if you observe the image thoroughly, you will be finding that the C section is symmetrical about the x-axis. So let me just draw the x-axis over here. So it is having the symmetry about the x-axis, and it is just that we need to recall the formulas of the moment of inertia of rectangle. So as there is a symmetry due to the x-axis, you can recall or you can frame a logic over here. So let me just help you with that. So the dimension that is perpendicular to the x-axis should be raised with the power of 3. So there are three rectangles. This is rectangle number 1, rectangle number 2, and rectangle number 3. And here the rectangle 1 and 3 are identical. So I1 and I3 will be equal, and that is equal to the base is 60 and the height is 20 divided by 12. And remember that the dimension which is perpendicular to the x-axis must be raised with the power of 3, that is 60 into 20 cube divided by 12. And for the inertia, that is inertia of area 1 and 3, it is not exactly on the x-axis. So for that reason we will apply the parallel axis theorem. So the distance between these two axes is 150 plus 10, that is 60 mm. This would be 60 mm is the perpendicular distance, and area would be 60 into 20 into square of the perpendicular distance, that is 60 square. So if you recall, the formula is like I is equal to I bar plus a times of d square. So I is the moment of inertia about the centroidal axis. So this is the centroidal axis for 1, and it is the same for 3 as well. They are symmetrically placed from the x as they are symmetrically placed from the x-axis, okay, for the areas 1 and 3, and this will be I1 and I3. So upon calculation, this would be 480000 plus 60 into 12 is 1200, 1200 into 3600, and this is equal to 4320000. So this is equal to 9120000 millimeter power 4. This would be the area moment of inertia for the areas 1 and 3, and for the second one it would be I2, that is equal to 100 into 20 divided by 12. The dimension that is perpendicular to x-axis should be raised with the power of 3, that is 100 cube. It is 100 cube into 20 divided by 12 it would be. So now this area is exactly lying on the x-axis, so the term AD square will not be present over here as it is directly on the centroidal axis. The distance D has become 0 now. So this is 3,333.33 millimeter power 4. So now the total inertia, that is I net, will be equal to I1 plus I2 plus I3, and that is equal to 9120000 plus 3333 So this is 9594 94533 333.33 mm power 4 would be the total moment of inertia. State parallel axis theorem and write its equation. So here the statement is the moment of inertia of a body about any of the axis parallel to the centroidal axis is equal to moment of inertia about the centroidal axis plus the product of body's area or the mass and square of the distance between the axes. So this is more or less an elaboration of a mathematical equation. So let's say this is some lamina or some area, or it could be a mass also. So the moment of inertia about this axis, that is x dash axis, and let's say this is the centroidal axis, say it as xx, and now the moment of inertia about the x dash axis, let's say it is I, that can be expressed the moment of inertia about the centroidal axis plus area into d square, that is this will be ICM, that is I subscript cm, that is moment of inertia about the centroidal axis. So if it is area, then we write it as I subscript ca, that is moment of inertia about the centroidal axis, or even sometimes this is indicated by I bar plus a times of d square. This is for area moment of inertia. Area moment of inertia. Same expression can be also written for mass moment of inertia, that is I is equal to I bar plus m times of d square, or this could be also written as ICM plus m times of d square. So ICM is the moment of inertia about the center of mass, or where the mass is assumed to be concentrated, the axis passing through it. So we'll be making use of these two relations in the analysis of structures. That is, this part of moment of inertia will be taken into strength of materials, wherein you understand the strength of cross section, and the other equation will be taken care in a chapter called dynamics, wherein you try to understand the motion of a complex body or which has got complex shape. And for the complex shape, it is recommended to predict the position of center of mass. So this formula you will be finding in kinetics, that is a branch of dynamics, and you will be finding this in the strength of materials and design of structures, etc. State and explain the principle of conservation of momentum. So here the statement is, in an isolated system when no external force are acting, that means external force are absent, the total momentum of the system remains constant before and after any interaction. That interaction could be in the form of collision or explosion or exchange of velocities. So here is the further explanation. When the two bodies in a system interact, when they interact, they collide, they may exchange forces or change their velocities, but the total momentum of the system does not change, provided no external force acts on the system. So here what it says, before the exchanging of velocity, whatever the momentum was, the same momentum will be maintained even after the interactions. That is, initial momentum is equal to final momentum. So momentum is given by product of mass into velocity. So let's say we have got two masses m1 and m2, and both have got initial velocities u1 and u2. So initial momentum would be of the combined system, that is m1 u1 plus m2 u2 equal to m1 mass will have the final velocity after the interaction as v1 plus m2 v2 it is. And the principle of conservation of momentum is a fundamental law of mechanics, and it is applied to all the collisions, recoil of guns, rocket propulsion, and other motion related phenomena. State the work energy principle. Work energy principle states that the net work done on the body is equal to change in kinetic energy. So due to the work done on a body, either the kinetic energy is going to increase or it is going to decrease. So here, if we go back to the fundamentals of Newton's second law, that is force is expressed as mass into acceleration. So here F is equal to mass. Acceleration can be written as dv by dt. And next is here, instead of writing the acceleration as dv by dt, the acceleration can also be expressed as a is equal to v square minus u square by 2 times of s, which is v square minus u square divided by 2 times of s it is. So here you will be getting the product of force into displacement, and that is equal to mass into v square minus u square by 2. So which is in short kinetic energy final minus kinetic energy initial, which is nothing but delta Ke. So this is the work energy theorem. Again, it is derived from the application of Newton's second law, and along with that equations of motion are also included into it. In a question, it is mentioned about a stone which is projected upwards with a velocity of 110 meter per second. With what initial velocity should a second stone be projected upwards after 2 seconds later so that it may overtake the first stone? So first is that we need to calculate what is the time taken by the stone for it to reach the maximum height. So initial velocity is given as 110 meter per second, and time taken for here, it is the time of ascent, that is t is equal to u by g, and this is equal to 110 divided by 9.81, and that is approximately equal to 11.224 seconds. Now the maximum height attained by this stone will be h is equal to u square divided by 2g, that is 110 square divided by 2 into 9.81. So this is equal to, this is 616.717 meters. This is the height attained by the stone. Now the second stone is being projected after 2 seconds. So time taken will be for second stone, that is 11.224 minus 2, which is 9.224 seconds it is. So here in this case we need to calculate the initial velocity. So h is equal to, that is ut plus half gt square, or here it would be against the gravity, that's why it becomes minus half gt square. So h is the same distance, that is 616.717, equal to initial velocity is to be calculated. The time taken is 9.224 minus half into 9.81 into time is 9.224 whole square. So upon calculation, the value of u will be equal to greater than 110. So that comes out to be as 112.41 meter per second. In the question, it says about a ball whose mass is 1 kg and it is thrown vertically upwards with initial velocity of 10 meter per second. The maximum height reached by the ball is to be computed. So here we can make use of the formula directly. Let's say initial velocity u is 10 meter per second and mass is given. So since we are dealing with the kinematics part, and as such the mass is not required to be taken into consideration, so height of the ball will be given by h is equal to u square by 2 times of g. So initial velocity is 10, that is 10 square divided by 2 into 9.81 it would be. So this, upon calculation, we would be getting the answer as 5.09 meters will be the maximum height reached by the ball. In the question, it says about the estimation of height of the tower from which a object is falling freely, and during the last seconds of its motion it is covering a distance equal to two-thirds of the height of the tower. So let's say that the object is falling somewhere from here, and let's say this is the height h of the tower, and the two-thirds of the distance, that is 66% of the distance, is covered in the last 1 second. Okay, so this is indicating the initial position of the ball, that is t equal to 0. This is final position when time is equal to t seconds, and this is the position of the body at time equal to t minus 1 seconds it is. So now the distance covered is two-thirds of h. So for this we need to write an equation, that is distance covered is equal to two-thirds of h equal to, now the distance, now here the distance covered in the time span of t minus 1 to t seconds can be expressed as, so now we can write, first is that we need to write h is equal to ut plus half gt square. So here the initial velocity is 0 as it is dropped from the top. So h is equal to half times of gt square. And next is, now the two-thirds of distance is covered, that is two-thirds of h is equal to the distance covered by the body for t seconds is actually h, that is half into gt square, and distance covered by the body from 0 to t minus seconds, t minus 1 seconds, is half of g into t minus 1 whole square. So in this duration of last 1 second, the distance is two-thirds of h. So two-thirds of h can be written as half of gt square, and this is equal to half of gt square, and this is half of g t minus 1 whole square. So upon solving, we would get this as 2 and 2 will be cancelled, g and g will be cancelled. Okay, so this would be, half is being cancelled, half will be taken out as common, or else we can do one thing, yeah, we can take out half as common. So this is 2t square equal to 3 times of t square minus t minus 1 whole square. So this is 2t square equal to 3 times of t square minus t square minus 1 plus 2t it is. So this, upon simplification, would be 2t square. T square and t square will get cancelled, that is within the bracket, and this is 3 ones and this is 3 twos. So this would be 2t square plus 6t minus 3 is equal to 0. So we need to solve for the roots, that is t is equal to minus of minus 6 plus or minus b square, that is 6 square is 36, minus 4 into a is 2 into c is 3, divided by 2 times of a, that is 2. So this is 6 plus or minus 36 minus 24 it is. So 36 minus 24 is 12, that is root 12 can be written as 2 root 3 divided by 4 it is. So this is 6 plus 2 root 3 by 4 is one answer, and second would be 6 minus 2 root 3 divided by 4. So 6 plus 2 root 3 by 4 is a value that is greater than 1, as we are going to calculate the time for last 1 second. So the value, the total distance covered for the height h has to be more than 1. So 6 plus 2 root 3 is approximately equal to 2.366 seconds, and this is slightly less than that. This is 0.633 seconds. So this is not a right answer. This is not a right answer. So the height h can be computed. H is equal to half into g into t square. That is half into g is 9.8 into, it's 9.8 into 2.366 square it will be. So now upon calculation, this is equal to 27.45 meters. If this session made engineering mechanics easier for you, like, comment your doubts, share with your friends, subscribe for more high quality engineering tutorials every week. Your support helps the channel grow and reach more students.